Kia ora. My name is Ben Eyers. I'm a builder from down in Wanaka. I was born in Christchurch, but I grew up in Wanganui, distantly but kind of under Mount Taranaki. So Hiberna means winter in Latin, and it's been a building company I've worked with for about 15 years, and I suppose I'm gonna take the moment to sort of talk about how I ended up building these straw panels. Generally speaking, these materials, in my opinion, have just been more fun to work with, so this is kind of a bit of a selection of the more fun projects that I've worked with. So early in my career, I was lucky enough to build a house for my parents, who basically said yes to every mad idea I had, one of which was lime plastering the inside of the house using quicklime slaked lime. So that's a picture of me and a cousin of mine doing hot slaking. They also said yes to some rammed earth. So we did a lime stabilised again rammed earth wall there. That was pretty mad. Through that, I suppose, a few years later, I ended up living in the UK and ended up in West Africa, working with a friend of mine, and we got the chance to build a lime kiln and do this Cadillac plaster over these outrageous earth brick domes. And I like telling the story of a friend of mine who was helping. He happened to be in Iceland just before this, and I made the kind of passing comment, "Oh, bring me some Cadillac polishing rocks." Does everyone know what Cadillac is? Okay, so Cadillac is a plastering technique which you do a bit of, right?
I know a bit about it.
Yeah, developed in Morocco, where you put multiple layers of a fine lime plaster and then polish it and compress the surface with a stone, and then use a natural soap, and you end up with this kind of waterproof surface. Yeah. Anyway, so he bought these Icelandic rocks back from Iceland, and it turned out that in West Africa there's just about no rocks. So I like thinking that hopefully still to this day there's a crew of Africans working with Icelandic Cadillac polishing rocks. Who knows? Oh yeah, sorry, I should go back. When we were working on this was at like a eco retreat place in the Gambia, and they didn't set aside this as not to be used when we were working on it. So we were there, and we were kind of like 6 of us grinding on the surface of this thing, and if you can imagine like the reverberation of the noise, there's people staying in there. And they were not impressed. But it turns out that they lived literally like 4 blocks away from my flat in London, and I ended up working for them for about 4 months, rebuilding this artist studio there. And I made the comment that I'd recently done this traditional timber framing course. And they immediately said, "Can you rebuild the glass roof out of oak for us?" So I called up a friend of mine from Germany and said, "Hey bro, come over, we've got this job and I need your help." And I guess that was kind of the first foray into kind of prefabricating stuff, learning to use SketchUp and that kind of thing. Then back in New Zealand, I spent the next few years predominantly working with owner builders, doing straw bale houses, and working with them, hand plastering these buildings, which is it's brutally hard work, basically. This project here, I worked out there was around 50 tonnes of plaster in the whole thing. That was later on when I got a plaster pump, and so I wasn't doing that anymore. But I guess, yeah, so working with these owner builders, sort of trying to figure out a better way, an easier way of doing it, a way that means it's more possible. And I ended up working on a bunch of projects where I wasn't the main contractor, and I was just doing the straw installation and plaster pumping. So figuring out a earth plaster, earth and lime or both plaster that could be pumped easily, wouldn't just run off the wall, wouldn't erode. So that's some erosion testing that we did. So that's erosion testing the plaster and the panel over there, which I'll talk about in a bit. All you kind of need to know is it works. Yeah, so what I ended up doing is using clay and oversaturating that with water, and then bringing it back to a good consistency using quicklime, which means it continues to kind of react and sets up on the wall a bit. I don't know, a bit later on, I built these buildings in Whaihanga, Luggett. Both of these I prefabbed either the roof structure or, in this instance, the first floor. And to be honest, a lot of this was for a friendly argument I had with another straw bale builder, that you had to put the roof on first, and so the general way, Min had a good picture of it in one of her slides, of a couple of guys working with a stack of straw bales. So what you do is you you sort of put the first 4 in, and then you make it so that the space for the last one, the 5th one, is slightly less than a bale, and then you get bottle jacks or scissor jacks and compress those 4 down, and then jam the last one in. It's really awkward, and as a builder, you just kind of think there's got to be a different way of doing it. And so I stacked up the straw like this, and then the structure is this box beam with these timber frame tenons. So the box beam for the first floor would come down and sit directly on the straw, and then compress down and then seat onto the tenons of the posts. It worked mostly, and I got to play with cranes, so that was cool. That's a little bit of a detail of a window jam. So this is the first straw bale certified passive house in New Zealand, and so that's just kind of demonstrating how we dealt with thermal bridges around windows by using this kind of timber system of posts, not buck and beam, and getting the window to sit really close into the insulation around the windows. But what I really wanted to do, I suppose, by that point was try and scale up and figure out some kind of a prefab system. I'd recently been over at the European Straw Bale Building Conference, and has anyone heard of a company called EcoCocon in Europe? They're doing just amazing work. They've done, I think, 50,000 square meters of straw panels in Europe. I think 7-story buildings, huge things. And so I was really inspired by what they were doing, and had a bit of a light bulb moment seeing what they were up to, using straw as a resource, not just straw bales, which farmers call idiot bales for a pretty good reason. And yeah, so they were able to get this really uniformly dense wall system with these easy flat surfaces, which was just a great substrate. They just screw together really easy, and it removes the need for specialism in the construction sector to be able to use these products. So I spent quite a lot of time looking into that, and so that's the kind of part of the first press that I made. So we literally just using loose straw and compressing it into this timber form, and then trimming the surface off. This is the first building we made, and still kind of my favourite really. It's a little 22 square metre sleep out. Built it kind of in the driveway of my house, or not, the machinery was in the driveway. And yeah, I guess it showed us that it was labour intensive and it was slow and it was difficult, but we were happy enough to kind of push forward and confident that we knew what we were doing and could improve it. So from that point, I built 2 further houses in a different setup where we built a double garage first, and then set the machinery up in there, and then had the driveway space to use to build these panels. Plastering on there flat, obviously, plastering on a vertical surface, things run off. So that's an amazing labour saver. There were a bunch of things that are different to these than what we're doing now. I won't go into those necessarily. But yeah, it worked. That's the Froggy Bottom project, which I think is on the website somewhere. Those are 4.6 metres high. You can see there's the diagonal bracing, which for this project, which we had it on the exterior. I've since moved to putting it on the interior because if it's on the outside, you have to kind of chase it into the surface, which means chainsaws, and you make this panel and you trim the surface and it's this beautiful smooth surface, and then you get chainsaws out and ruck the surface up, and it just looks awful. And so yeah, we moved to putting them on the inside, and we figured that they could just sit underneath the plaster surface, and also more durable, having that metal on the interior. On this one, they treated the ex-designer on the outside as an air tightness layer, and yeah, to be honest, I think I'd advocate for that really, especially in a situation like this one where they had wood fiberboard on the outside to boost the numbers a little bit. I think they got 0.35 air changes per hour at 50 pascals. We'd done a few where, so this is the inside. See the blue around the outside, that's Contiga tape, which is a Proclimer product which you stick onto the side of windows or onto the building membranes around the ceiling and then embed it in the plaster. It's a lot of work basically, and so I think using focusing more on having that membrane on the outside just makes it easier to achieve air tightness levels, and you're still going to have a pretty well sealed wall for air tightness just plastering it. So this is those are the panel joints, so kind of like a sheet of jib. We don't plaster quite to the edge, then the panels skew together, and then yeah, just jib stop effectively, but with the same plaster and a sheet of mesh to join them, and then top coat over it later. This is some hydrothermal modelling that Jason Quinn did from Sustainable Engineering. So we wanted to see theoretically how would this wall system perform in kind of a worst case scenario. So this is a house in Island Bay, and this is the wall. So you can see the green line is humidity, red is temperature, and it's when those two cross over at the 0.8, so that's 80% humidity, that's kind of the danger zone. And so, yeah, it works even in that sort of position with the cook straight right there. The key being, having the thin plaster layer on the exterior underneath a wall cavity so that any internal moisture can dissipate into that clay and then out through the cavity, which stays dry. That's the Froggy Bottom house finished. I've put that there to sort of demonstrate that these products can be quite contemporary houses. These guys wanted something quite contemporary, not like the kind of classic rounded straw bale window reveals, which I personally quite like. I think that the light reflects really well off them, but they wanted something else, so that's what they got. These are a few photos of where I'm set up at the moment. Various bits of machinery, the press kind of coming or going, I'm not sure. Again, plastering horizontally. This is a P21 test we did with just a set of crane scales basically, and a truck strop. I haven't done a whole series of those, so I couldn't really tell you numbers. Yeah, probably ripping through this a bit fast, aren't I? Okay, yeah. Right, okay. That's the last slide. Yeah, so...
Why is it called Froggy Bottom?
Why is it called Froggy Bottom? There's a big pond, and one of the clients is I think she's an air quality scientist for ECAN, and she's into frogs. Yeah, and there's a big pond. So this straw, we grow it kind of by accident, and you can use it to make your houses warmer.
Yeah. I was just interested in what the difference in labour time might be with your
on-site
SIPs.
Or for me, off-site, hidden somewhere that you can't see, and we'll just pretend doesn't happen.
I guess both. Like if we were talking like designing for an affordable build, how would this compare to a traditional 3604 timber frame building with BATS insulation in terms of the time, like the labour cost?
Pretty similar in terms of time to put the walls up, if it's just the walls. Maybe a bit faster. Pretty similar to SIP panel, really.
Mm-hmm.
Like, what did we do recently at the Nelson one? We did, I suppose it was 60 square metres in like 2 half-ish days installed, but then there's still the plastering. So fairly similar, but currently, if I'm brutally honest, off-site, where I'm building these, there's still quite a lot of labour. Yeah.
And the follow-up, because I love the idea, is it something that you're planning on scaling up and kind of like licensing other people to build your panels in different locations? Say, for example, if I was designing something in the far north.
Mm-hmm. I would love to send them all around the country. I'm definitely working on scaling up. Ultimately, I'd like to make something that could potentially compete with tilt panels. I think the way that we make these, there's not really a limit on the height apart from timber that you can get, so 6 metres, apart from materials handling. So I'm currently working in a wool shed. It's better than it has been, but To answer your question, yes.
Just really wonderful content in all ways. In terms of your construction program, it looks all of those in nice weather. I suppose you have to work out a particular time of the year to do your construction program?
Not necessarily. Not necessarily. So we make them with a flap of, excuse me. With a flap of a breathable building wrap on the top. So they come kind of protected for rain and then coated on both sides with a plaster. So this is the exterior. So not really. I mean, frost would be a problem for sure, but I mean, don't you wouldn't put them in pouring rain for sure. But
that's why I was thinking it looks really good, the concept in terms of your program throughout the year.
I live in a desert, basically, in central Otago, so slightly different up here, and that's why I sort of talked about cavities, and that's what I would definitely advocate for up here, is cavities and other building systems, other coating systems.
Why is frost such a problem? For an ignorant person.
Frost, if you put wet plaster on a wall and then it freezes, ice crystals form in the plaster and it just turns to powder and falls off. So, yeah.
It's just the weather.
Yeah.
Do you use any fire retardant in the
No, there's been so many tests around the world of other people making these kinds of things and getting really good ratings for fire. That's kind of another reason why I put the plaster on the outside as well as the inside. But yeah, it's the same as large timbers. A large piece of wood won't burn, right? So there's no air in there.
I was just going to ask about the external cladding for waterproofing and sort of durability, because I did a project in the far north, and the weather was challenging, and if using the earth building codes, it's kind of like, would it come under an alternative solution, or is it covered by the New Zealand standards as a cladding?
The plaster,
yeah.
Or it comes back to these basically.
Okay.
Yeah.
And so, as you mentioned, the cavity option, is that like just an additional layer of protection?
Yeah,
Optional?
I would probably not go direct plaster on a straw bale building kind of in the top half of the North Island, or if you're too close to the coast. Unless, my experience is down in central Otago, so you'd need to do hydrothermal modelling to answer that question, but yeah.
Cool.
It's also to do with the design of the building, isn't it?
Yeah.
Like if it's got eaves or not,
Yeah.
or if it's got a veranda all the way around it or something,
Yeah.
where the prevailing weather's coming from. So there is that kind of analysis in the code. Yeah, I'm with Ben. I'd be mostly wanting to do a cavity.
Yeah.
I'm just curious about your timber that you use, if it's treated or if it's Douglas fir or...
Yeah, so Douglas fir for the side, so that's 27 by, this one's 250. Untreated Douglas fir. There's tons of it in the South Island, less in the North Island, I believe, but there's plenty of it. And then it's just pink 4x2 for the rest of it, because that's what's available. And yeah. Cool.
Last question.
On to the next one.
Sorry, Ben, I'm going to be that guy. Obviously, the value of these is really high, but when it comes to cost, have you done any comparisons between more standard building? Because obviously the materials might be cheaper, but the labour's more, et cetera.
Pretty close to a high-performance house of the same R value.
Cool.
Yeah. Thanks.
Thanks, Ben.